No cranes, no engines, no steel cables. And yet, more than 4,500 years ago, the ancient Egyptians moved stones so heavy they still feel impossible today. Some of those stones were routine building blocks. Others were monsters. Granite slabs cut in the south, hauled across desert, loaded onto river barges, dragged up ramps, and locked into one of the greatest monuments ever built. Some of them weighed close to 70 tons. That is not just heavy. That is terrifying, because a stone that size does not forgive mistakes. It does not wobble politely. It does not stop because people are tired. If it slips, men die. If the line breaks, the system fails. If the route is wrong, the stone wins. So the question is not just how they built the pyramids. The real question is this: how did the ancient Egyptians force something that heavy to move at all? For centuries, that question has triggered wild answers. Lost technology, secret machines, unknown powers, even aliens. But the deeper you look, the less supernatural the story becomes, and the more astonishing it gets. Because the real answer is not one missing machine. It is a chain of brilliant solutions, each one solving one part of the problem. Sledges, wet sand, ropes, ramps, Nile transport, human coordination on a national scale. To understand how it worked, we need to follow one giant stone, from the moment it is cut from the earth to the moment it locks into the pyramid. And that journey begins far from Giza, in the granite quarries of Aswan. Aswan is where Egypt found some of its hardest and heaviest stone. Granite is dense, brutal, unforgiving. It does not split easily, and it does not care how badly you want it. Ancient workers had to attack it with pounding stones made from even harder rock, smashing the surface again and again, carving channels into bedrock with raw impact and patience. There were no explosions, no engines, no hydraulic saws, only repetition. Strike after strike, cut after cut. A future block emerged slowly, like an animal being freed from stone. Workers carved trenches around it, deepened the channels, defined the edges, reduced the bedrock's grip, and after enormous effort, the block finally loosened. But cutting the stone free was only the beginning. A granite block lying in a quarry is not yet useful. It has to be shaped, squared, balanced, prepared for movement. Only then could it become cargo. And that led to the next terrifying problem. How do you place a giant stone onto a wooden sledge without wrecking the sledge or crushing the crew? This is where simple tools become extraordinary. Levers, ramps, wooden runners, rope. Nothing glamorous, nothing futuristic, but every piece matters. The stone is eased into position. The sledge groans under the load. Bindings are tightened. Wedges are set. The block is no longer part of the quarry. Now it is a moving threat, and the desert is waiting. At first glance, dragging a heavy object on a sledge across sand sounds insane. And on dry sand, it almost is. A runner sliding across dry, loose sand does not glide cleanly. It digs in. It plows. It pushes a mound of sand ahead of itself, building resistance with every inch. The heavier the block, the more vicious that resistance becomes. So the Egyptians did something brilliant. They changed the ground. One of the best clues comes from ancient art. In a famous tomb scene, a worker appears to pour liquid in front of a massive sledge. That tiny detail may be one of the biggest secrets in ancient construction, because when sand is dampened correctly, it changes. The grains bind together more firmly. The surface becomes stronger. The runner does not sink as deeply. The ridge of piled sand in front of it is reduced. The pull becomes more manageable, not easy, never easy, but manageable. The Egyptians may not have written modern physics formulas, but they understood the behavior of materials through experience. Too little water, and the sand stays loose. Too much, and the surface turns to mud. But the right amount creates a better road. Now imagine the scene in motion. Ahead of the sledge, water carriers pour from clay jars, darkening the path. At the ropes, dozens of men lean forward together. A foreman calls the rhythm. Bodies tighten, hands lock, feet press into the sand. The order comes. Pull. At first nothing, then a creak, then a violent groan from the timber. Then the block shifts. Only a little, but in a machine like this, a little is everything. Again, pull. The line moves. Dust explodes around the feet of the haulers. Ropes vibrate. Men grunt in rhythm. The block surges forward. This is the real secret of ancient Egyptian transport. Not one burst of impossible strength. A sequence of controlled movements repeated without failure. The sledge matters. The wet sand matters. The rope matters. But none of it works without organization. A giant load cannot be dragged by chaos. The line must stay straight. The crew must move together. The route must be prepared before the stone arrives. The foreman must control timing. The path must be kept stable. If the line twists, the load can drift. If the rope snaps, the crew can die. If the road fails, the stone stops dead. That means the real machine is bigger than the sledge. It includes the rope makers, the carpenters, the road crew, the water carriers, the overseers, the scribes, the planners, the state behind the entire operation. And for the heaviest long-distance loads, even the desert haul was not enough, because the Egyptians had something else: the Nile. The Nile was not just a river flowing through Egypt. It was Egypt's superhighway, a moving corridor linking quarries, settlements, harbors, farms, and construction zones. Over land, every meter of motion cost strength. On water, distance changed character. A load that is nearly impossible to drag for hundreds of kilometers becomes transportable if it can float on a strong enough vessel. That does not make the task simple. It only changes the kind of danger. Now the problem becomes loading, balance, and control. The giant block has to be brought to the water, transferred onto a barge, secured so it does not shift on the deck. A stone that lurches at the wrong moment can crack timber, wreck the vessel, or kill the crew. So loading the barge is an operation of its own. Ramps guide the mass. Ropes restrain it. Crewmen brace it from the sides. The deck is prepared to take the weight. And when the stone finally settles on the vessel, the whole mission changes. The Nile takes over. Now, the current helps. The sail helps. Tow crews and oars help. What the desert could only resist, the river can carry. This is one of the most important things to understand about the pyramids. They were not built by one trick. They were built by a supply chain. Quarries produced the raw material. Workshops produced sledges and rope. Boat crews moved cargo. Harbors received and released it. Road crews prepared the path. Surveyors controlled direction and alignment. Bakeries and brewers fed the labor force. Scribes kept records. Foremen synchronized the crews. Every part depended on every other part. Even the documentary evidence points in that direction. The Diary of Mera, an ancient papyrus record from the time of Khufu, describes teams transporting stone by boat during pyramid construction. That single document is powerful because it shows something crucial. The builders were not improvising. They were operating inside a managed logistical system. And once the cargo reached the Giza area, the cycle returned to land. Unload from the barge, back onto the sledge, back to ropes, back to men, back to the grind of friction and control. Only now, one challenge remained above all others. Height. Dragging a 70-ton stone over level ground is hard enough. Raising that same mass higher and higher as the pyramid grows is a completely different nightmare. This is where ramps become essential. Archaeologists still debate the exact ramp designs used at different stages of pyramid construction. There may not have been one single design from beginning to end. Straight ramps are one possibility. Zigzag ramps are another. Some researchers suggest that later stages may have used more compact or even partially internal routes. What matters most is the principle. A ramp converts a vertical lift into an inclined haul. Instead of lifting a massive block straight upward, the builders drag it upward across distance. That does not eliminate the problem. It spreads the problem into stages, and staged movement is exactly how the Egyptians won. At the ancient quarry of Hatnub, archaeologists discovered a ramp system with side stairways and holes for wooden posts. That discovery matters because it suggests how steep hauling could have been controlled. Ropes looped around posts can create leverage. They can slow the backward slide of the load. They can give crews better control on punishing inclines. That means a steep ramp is no longer just a slope. It becomes a mechanical system. Picture the climb. The sun is brutal. Dust hangs in the air. The giant stone waits at the base of the incline. Ropes stretch upward like the tendons of a living creature. Workers line the route. Some pull from above, some stabilize from the side, some manage the posts. The foreman gives the signal. The crew heaves. The block grinds forward. Then it stops. Supports are placed. The line resets again. The next pull is just as dangerous. Again. That is how a monument rises. Not by one miraculous lift, by thousands of brutal, disciplined, controlled advances. And even then, the story is not just about engineering, because stone does not move without people, and people do not work at this scale without support. For generations, popular imagination pictured the pyramids as the work of endless, chained slaves. But archaeology tells a more complicated and more human story. Workers' settlements near Giza reveal housing, food production, organization, and care. These were labor crews inside a giant state project. They needed bread, beer, water, tools, medical treatment, rest, leadership, records. The visible pyramid was only the tip of a much larger system. Behind every placed stone stood a chain of support. Who cut it? Who shaped it? Who built the sledge? Who repaired the rope? Who poured the water? Who cleared the route? Who drove the barge? Who fed the crew? Who counted the rations? Who checked the alignment? Who gave the signal to pull? That is why the alien theories miss the real wonder. They do not make the pyramids more impressive. They strip away the intelligence of the people who built them. They erase the evidence carved into quarries, painted into tombs, written on papyri, and buried in work sites and harbors. The deeper we look, the less mystery there is about whether humans built the pyramids, and the more mystery there is about how capable humans can become when knowledge, labor, and organization lock together. So let us pull the whole process into one clear chain. A granite block is cut free in Aswan. It is shaped into a controlled load. It is mounted onto a wooden sledge. Workers prepare the route. Water is poured ahead of the runners. The block is dragged across desert in violent, controlled bursts. It reaches the river. It is loaded onto a barge. The Nile carries it north. It is unloaded near the construction zone. The sledge takes over again. The road leads to the ramp. The ramp breaks the climb into stages. Ropes, posts, and crews control the ascent. Levers and precision guide the final centimeters, and at last, the stone settles into place. Then the process begins again, and again, and again. Repeat that cycle enough times, and the landscape changes. An empty plateau turns into a construction zone. A construction zone turns into geometric mass. That mass grows into a monument. And the monument becomes something so overwhelming that thousands of years later, people still struggle to believe human hands did it. But human hands did do it, not alone in the sense of one hero, together, in crews, in chains of labor, in a statewide system that turned wood, rope, water, and stone into engineered force. So how did the ancient Egyptians move 70-ton stones without cranes? They broke the impossible into parts. They used sledges instead of relying on wheels that would fail in sand. They reduced friction with wet sand. They exploited the Nile for distance. They used ramps for elevation. They used ropes for force. They used posts and leverage for control. They used survey and measurement for precision. And above all, they used disciplined, organized human effort over and over again until the impossible became routine. The next time you see the pyramids, imagine them not as frozen stone, but as motion. The hammering in the quarry, the crash of chips against bedrock, the sledge creaking under load, water splashing onto sand, the foreman shouting the rhythm, the rope tightening in dusty hands, the barge sliding along the Nile, the crew dragging the stone up the ramp, the lever settling the block into place. That is the sound of the real miracle. Not magic, not alien intervention, engineering. Human engineering at a scale so vast it still overwhelms us. And perhaps that is the most powerful twist of all. Once you understand how the pyramids may have been built, they do not become less awe-inspiring. They become more awe-inspiring, because the true wonder is not that the builders had help from beyond the world. The true wonder is that they did not need it. The ancient Egyptians did not need cranes to move 70-ton stones. They needed intelligence, discipline, water, wood, rope, stone, the river, the ramp, and thousands of determined hands willing to do the impossible, one pull at a time. That is how the stone moved. That is how the pyramid rose. And that is how human beings turn the desert into one of the greatest engineering stories ever told.